Hey. Okay, we had a really good class today, talking about a new concept, order of operations. I'm wearing a shirt today that is very fitting. Show your work, thanks, said every math teacher ever. And as we move into these complicated math expressions, showing your work is going to become even more important. Why? Because as your teacher, I need to be able to take a look at what you were thinking when you got to your answer. And if you made mistakes, I can pinpoint where that mistake was to help you improve your math game. Other than that though, this is the beginning of a very exciting new chapter in math where things get tricky. Now you might think exciting and tricky don't go in the same sentence, but for me it does, because it means we're doing less computing and more riddles, more puzzles, more untangling. And to do that, we need to start nice and early with organized note-taking of what's going on in our brains, putting it on paper. Lots of studies also show that putting things on paper as you write or learn or think is all the better for the processing of it all. It's especially in math. Today we started order of operations. If you're given a complex series of steps, you need to follow the directions in order. And order in math has been given for us. You always want to start with, we introduced a new symbol today, parentheses. Sometimes parentheses are inside parentheses, and we change that to be brackets. You always want to start from the very, very inside. As you can see, I've got an example for us. After that, you want to do all your multiplication and division. Now, parents watching or older kids watching may recall that this looks a lot like PEMDAS. We just haven't introduced exponents yet. Shh, not doing that. So for now, we're just doing multiplication and division. Now notice that they are grouped together because you're going to do them from left to right. That means if you're given a division first, you still do it because it's left to right. You're going to go any multiplication and division left to right. Same thing with addition and subtraction, okay? So let's work through this one I've written here, and it's fairly complicated. Another lesson you learn in math is to not get too sticker shocked by things looking complicated, okay? Just like when we go home and we have a big to-do list, one of the things we learn as we grow up and mature is how to regulate that feeling, right? So get it out, and then let's tackle it. Let's think we can do this. We can tackle this. Now remember, we want to start with parentheses first, and we want to go all the way into the inside, but I've got brackets and parentheses. So for me, I'm gonna go all the way to the middle. Now once I'm inside the parentheses, your MDAS still apply. I'm lucky because I just have addition and subtraction. So 2 plus 3 is 5 minus 1, that makes 4. Now, notice I still have the rest of my problem that I am going to rewrite. This keeps me organized and makes sure I don't lose any steps. I really just rewrote the part that I've already tackled. Now I got rid of my parentheses because I did that, but I'm still on the P because I have these brackets. So 4 times 2 is 8. Okay? So now I've done my parentheses and brackets. I'm moving on to multiplication and division. In this case, you might do that accidentally, but I'm telling you, there are problems out there that have even adults questioning their steps. So it's important to just keep referring back to your code, despite it looking like you might notice what numbers have relationships and not. So 8 times 5 is what we're going to do next because that is the next step. Not because it happens to be first in the list. It's because it's the first in our order of operations. Even if this was something else in front with addition, right? Like let's say there was also a 1 plus all the way here. In fact, let's do that. I've changed it. Let's say I have a 1 plus 8 times 5 minus 7. No, you don't do 1 plus 8 first. You still want to tackle the 8 times 5 because we are in the multiplication division step. I'm going to rewrite the parts I don't know yet because I haven't addressed it, and I'm going to change the 8 times 5 to 40. Okay, let's move this up a little bit. Great, that was cool. In my head, I wanted it to go that smoothly, and it did. Okay, so now we've got our multiplication and division out of the way. We only have addition and subtraction now, so we will go left to right. It doesn't matter if there's a subtraction or an addition first. We are down to our A and S, so we will do that. Okay, I made it a little harder for me with that 1. 41 minus 7, 34. Okay, all right. Now this is being asked to break down an expression that's already been given to you. Another thing we're working on in class though is writing the expression ourselves. I wanted to go over some things, and we've got a poster in our classroom. Most math classrooms do have a poster, mine's over here, that has a bunch of key words you may know in math. So I told the kids today, and they were blown away, you know a second language, right? And they were like, Spanish, we're in Spanish. No, you actually are learning math on top of that. Math's not a language, Miss Vaughn. Yes, it is. You are asking to take what you see and observe and feel in English or whatever your native language is, and then translate that into math. Wow, that's a beautiful bird. Flying how fast? Bird equals 15 miles per hour. That's you translating. So in order to do that, we need to make sure that we get used to seeing what words mean what. Now, this is not necessarily something you need to memorize. Again, you'll get used to it as you learn the language. But notice, just for kind of making a point here, I have our operations and a sum or equal sign, and I want you to notice that there's different terms here. For example, subtraction, if you were reading a word problem, might not say subtract. They might say find the difference, or 6 less than 2, or take away 10. With addition, you might see something like the sum of these two numbers, the total, or increased by. Okay, multiplication and division, you've got the product of, or the more common, this times that. Quotient is a one you may have heard before, and now it's coming back. The quotient of 15 and 3 is 5. The quotient being the answer to division. And then in a word problem, you might see Susie, Timmy, and Tom shared the bag of candy equally. You're going to be dividing by how many people there are, shared equally. And then less common to think about, but just as important, is other words for an equal sign. Results in equals is, funny enough, almost all the time in math is an equal sign. So assuming that, let's do one example. This is what our kids are working on in class as well right now. Taking an expression and turning it, an English expression, and turning it into a math expression. I've given them the simple advice, since we're at the very beginning of this journey, of write what you read, and then we can add parentheses to make sure we do the right steps. Basically, you're going to be giving instructions to the person who reads your expression. So, the product of 2 and 7. Product was multiplication. Okay, the product of 2 and 7. Subtracted from. Oh, we're taking it from. Okay, so I'm going to put the subtraction sign in front. As in, I took 3 candies from the bag, right? Another helpful tip with word problems is to see if you can relate the terminology into something that makes more sense. Because words are going to sound, I know what they're trying to say, but what is it? And if you replace some of the story, no one told you can't do that, or replace the names with your friends' names or yourself, put yourself in the story, you may have a better time translating it. So the product of 2 and 7, check. subtracted from, check. Okay, the difference of 10 and 3. Difference is subtraction. Okay, this is a great example of where once we've read it and written, we need to also add some parentheses because we want to make sure you're very clear what you are doing. Parentheses help sort of break the PEMDAS apart. If you have something you need added first, like I bought 2 apples and 2 Cokes for each of my 3 friends, I might want to add those together before multiplying by 3, right? And addition and subtraction is not first in the list. So parentheses help guide you through any sort of weaving you want to do in the math expression. So product of 2 and 7, we're going to combine, and we're going to combine the second sort of phrase as well. Newsflash, can't really have too many parentheses. Parentheses are kind of like commas in English. Some people use more, some people use less. There's a lot of gray area. I hope there's no English teachers who will get me. Now I have to go ask our English teacher. Anyway, for me, I'm a big parentheses user. It helps me break things apart. But technically, we don't need the 1 from the 2 and the 7. We know that if I had no parentheses at all, I would go straight to multiplying because that's the first step in my PMDAS that I have. I have no parentheses right now. But I don't want to do that. I need to find the difference of these first. So I'm going to make sure that I add the parentheses. Okay, now this example is relatively simple. They get more complicated and those parentheses can be really, really valuable. Okay, so I wanted to go through some of those ideas. Let's do another one where we look at a word problem that has a story behind it. So notice this is a word problem, but there was no story. It's just math. This one has a story. And while word problems can be a bit intimidating, I find that the story is helpful because I can think about what's really happening. Sarah buys 6 axolotl toys for each of her 3 children. Each of her 3 children. 6 each. 3. Okay, I think she needs to buy 6 3 times, right? And then again, I'm gonna just go ahead and put that in the parentheses. It helps me organize. All right, let's see here. Let's keep reading. So Sarah buys 6 axolotl toys. See how I didn't even get to the end of the problem before I was already translating? You're gonna get there. Sarah buys 6 axolotl toys for each of her 3 children. While each is not a technical term in math, that is a nice hint to get us to where we need to be. Oh, she also buys 2 for herself, okay? We are going to take these word problems and break them down into expressions, okay? I love this part of math. It starts to get exciting. You start to really want to play with the riddles. So hopefully this will help if you have any of this homework, order of operations, or translating expressions.